Greetings, this is Koiro with another video in the Leningrad series. In this part of the video I will try to assemble the kit as far as it goes. I will place most of the components on the board, and I will also stop and tell you about some of the problems that I had with this and some of the design issues that we have run into along the way. And all the soldering and placement of components is played in 5 times the speed. And I will get back to you with some comments along the way. And if you want me to do a video about soldering, I'm more than happy to do that. But this is not going to be that video. Yes, quite an easy way to turn the board with all the sockets inserted. Now I'm just fastening each socket with soldering the end pins to keep them in place, and I will do the rest of the soldering of this later. Also, if you just solder the end pins, it's much easier if some sockets don't get stuck straight to the board. If there are some openings, it's easy to fix that by reheating the solder and just push the chip towards the board. As you probably saw when I was doing the fastening of this socket, I actually had some trouble with fitting these broader sockets into the PCB. And what is the case is that when I try to fit this socket in here, there are actually some misfit between the width between the legs. So actually there are something that's not quite right with the scaling of this PCB. It is possible to fit it in here, but I have to push really to get this socket in place. And it might be the scaling of the PCB, it might be the parts library that was used to lay out this board that was bad, but I'm not going to use this socket for this. To make sure that this will be okay, I'm going to use this socket here. This is very high quality sockets, and it's much easier to get this to fit. You can still see that there is some difference between this, because the width between these legs are bigger than this, and the width between those legs is the standard, that it's 1/10 of an inch, so it's 2.5 54 millimeter between in the center to center from each of these, and this is probably something more aligned with 2.5 exactly. But I'm just going to use this as socket, and that will be a very good solution for this. And as mentioned earlier, this socket is not meant for an IC. This is for connecting the keyboard. So we have to see about that later to make a connector that fits into this. As I mentioned earlier, this is exactly a bit too wide on the board to make this fit, but this is not a beauty contest, so I'm just going to push them in place. It doesn't matter if the feet is maybe 2 or 3 millimeter above the circuit board, because it still won't get above the top of the ICs when I put them in the sockets. If I've been checking, I probably would have had 100 nano capacitors with more distance between the legs. Here you can see they're in all different kind of shapes. This is about 1.8 centimeters between the holes. This is about 12 millimeters, and this about 10 millimeters. So it differs a lot. Here I think they have actually cheaped on in the design, and they share one decoupling capacitors among 2 of the chips, and if I remember correctly, this 8 upper chips here is the memory chips. I'm running out of these caps now, so I have to check on the schematics to see that I'm using these right. Just going to turn on the fan to vent out the smoke from the soldering. I was 12 years old when I got my first soldering iron, so I've been doing this for quite some time. Yes, and sorry about the noise of the exhaust fan for soldering, but it's quite a strong fan that actually takes the smoke from the soldering and lead it into a pipe that leads outside, so it's very good ventilation for these toxic fumes. Back in the day when I was learning this, I learned that you should always cut the legs of everything before you solder it in, because this snap, when you are cutting this, would always make too much of a physical pressure on the solder joint. And that of course was true when you had bad cutters like this, where this was made so the force actually was quite just as big up as it was down, because this was almost an exact triangle on the knife of the cutter. But on these, where the biggest angle is on this side and there is just a small linking on this side, when you push here, all the pressure will go upwards, so this doesn't hurt the joints at all. Yes, before I started cutting, I wonder which one I had forgotten, and it was of course this one, because there always is one, at least. The problem with these cutters that's so little angle on this side is that you risk cutting this too close, so you risk cutting away half of the solder, and that's not the point. Yes, now I will try to place the rest of the known components, and I start with diodes, and I will continue afterwards with the resistors. The diodes that's used here is the quite common 1N4148 diode, and there was quite a lot of them. Some of the diodes is not pointed so they're flat to the boards, they're raised upwards, and there are no markings what side should be the anode or cathode, and that's quite annoying. The silk screen to make that right won't be much of a trouble if you lay out the board correctly. And PCB in itself is so cheap these days that to fix the layout so that you could have every component flat to the board would not require much in the stake of cost. Of course, if you don't use surface mounted components, the board will be slightly bigger, but I think that's a small trade-off to be able to mount the chips on an orderly fashion to the board. And here I actually had to use the continuity tester to check against the schematics for placing the diodes the right way, as there was no markings on the board. So I looked into the schematic and measured out for where the diode should be regarding the key matrix on the socket. The good thing about that is that I got to know the keyboard connecting socket better, and I now better understand how the keyboard should be connected into this socket when we come that far in the process that we need to make a cable to connect this. The board that is used on this project is plated with tin, and this is probably lead-based tin that's padded on the solder pads, and that makes it quite easy to solder. The gold or copper plated pads, it's much harder because they oxidate in another way, and the flux that's in the solder wick actually helps to make this solder quite easy. If I have been using a copper plate or gold plated board for this, I would have to clean it, and if you put the project away for some time and take it back out, if this is copper based or gold plated, you probably should wash it each time, but with these tin plated pads that's not really an issue. If you have good solder with good flux, resin based, it's very easy to solder this. This time in the project it became apparent that not everything was totally okay. Some of the resistors was missing, some of the capacitors does not have the values that's stated in the schematic, and we can see on the web pages that there are some fixes and slightly changes that's recommended to the board, but this is not very well documented, and it's not just our poor Russian technical reading skills that comes into play here. It actually is some difference between each fix, and what you see I'm making here on the bench is that I actually making the resistor network that should be put in place here. It's much easier if I solder it first and put the components on the board. I actually considered to put the resistors and solder them to the board and make the connections on top afterwards. But I think it's easier to make this right with soldering outside. I did this outside. And these high pointing resistor networks as this, where you have the ends stand up, it's quite an antenna, and if this runs with the CPU frequency, it's quite a good way to make noise into the board, because in 4 or 5 megahertz range these resistors that point up in the air and have long leads can actually be a source for injecting noise into the system. Yes, here you see me making the next network, and this is an even harder job because this has to be made in a 90-degree angle, and this is to be placed around the keyboard socket. But this is also a 15K resistor network with a common node. So a typical bus transceiver termination or pull-up. This project has impacted the way I'm going to do this kind of video in the future. The footage that I took with my iPhone was not very good. It was often difficult to make the phone make the movie in the right direction. It often tilted the image, and it's problematic to have these large videos transferred out of your iPhone on a Windows computer. I used a lot of time with that, and the videos that was filmed so they was flipped 90 degree or 180 degrees. When I was making the transition into Pinnacle Studio, I actually lost quite a lot of the image quality along the way, so this footage was really grainy, and rest of the video is filmed by using the stream cam, and that's much better footage. I've now changed the angle on the camera a bit, and I also changed, so this is now being filmed with my Logitech stream cam. It's still a bit poorer picture quality than I would like, but I think that will do for now. I will continue to populate this board, and now it's the rest of the resistors, and then I will do some more of the special circuits like this transistor array and some other stuff, and these resistor networks that's custom made was actually a lot more fiddly than I think it would be. And I also made some strange design choices along the way. This here is a 15K resistor network, but instead of doing what you normally do and have the common pin on the end, they have put the common pin in the middle, so that means you can't use any standard pre-configured resistor networks. You have to make your own, and that's quite okay to make your own, but when you have leads like this and you are talking frequency up in the megahertz range, you of course will be prone to get some noise inducted into this. Yes, but then I will just continue to populate the board. This time in the process it was quite easy and few obstacles, because I was taking the easy low-hanging fruit first. I took all the good marked resistors, and down on that side of the board it's more space and everything is better marked. But as we will see, this is not the case everywhere on this board. I'm using Pinnacle Studio as the video editor program for this, and they don't have more than a 5x speed increase. That's not convenient in every way. You can see there are still some places on this board that's not populated with anything, and I am actually running out of components for populating some of the resistors. You have this 3K. It's said that there should be 3 pieces 3K in the kit. I have this one left that's dated 100K, and they've written on this that this is for tape, and there is one 100 nanofarad capacitor also in this, and that might be a coupling capacitors for coupling this to a tape deck, but I'm not sure where this should fit on the board. In this small bag where there are the other capacitors, there is no more resistors. So I know I am lacking some resistors. That's not a problem anyway, because I know I have them. But the problem is over here, where you actually has very little in the way of labeling of stuff. So I won't see any obvious clues to if anything is missing or not. But I will take them down one for one. I will first fill out this part of the board with the rest of the capacitors and the transistor array and these components down here. So when I'm finished with that, I will start with this corner over here, where there will be a lot more problems to identify if something is missing. The reason that I measured these resistors is that I have been seeing some cheap China resistors, and this comes from my own China stock. I have been seeing some of them mislabeled, so I've actually made a habit of measuring the resistors that I take out of my cheap China rolls of resistors. Now I will just continue on to solder the rest of the joints on this board that has not been soldered yet. So I will just cue to the music, and you can just skip this part if you don't find it very interesting. Yes, and now we are finishing up some of the last solder joints on the main PCB. There are still some components missing, but the larger part of the soldering on this main PCB is done. Yes, and here comes the easy part. The keyboard PCB was very easy to populate with the switches, and this footage I actually lost the first part of, but the soldering on this board is very easy, and this is a real high quality, well made hobbyist PCB, because the thin plated solder pads makes this soldering very easy. And you can see it's nothing that's difficult at all with this soldering process. When you take and heat the leg and the pad from one side, you just stick the solder on the pad on the other side, and the pad that's leaded will transfer the heat to the solder and make this a good joint with very little warming. Yeah, as you can see, I actually have cheated a bit, or actually what happened was that some of the footage I took when I soldered in the last components, this array, these capacitors here, it actually got lost. I got some crash on my iPhone, and I was not able to rescue the movies from there. After a couple of tries, I managed to get them downloaded to a Mac that I have for just that kind of purpose, but the video was not recognizable for editing or playing, so sorry about that. But to sum up what we have learned so far about the Leningrad 1 PCB, it looked to be a high quality kit with all the chips and other stuff supplied, but when we looked closer into this, it turned out to be some bottlenecks in the production, to put it that way. One thing is, you have down here, you have these resistors that should be connected with a diode before you mount them in place. That's not very hard to do, but when you lay out a PCB for production, you want to get rid of manual processes. And also when you do this as a hobbyist these days, you tend to lay out the PCB so that it looks very nice and tidy, and the quality of the PCB that's presented nowadays for kits and is produced by the high quality PCB manufacturers, you don't see this often anymore. And the same can be said over here. And you have this resistor network that goes in a 90-degree angle, and you actually have the common pin in the end here, but there are no ready-made resistor networks that's coupled like this. And this is also very close to where you should put the keyboard connector, so that means we might run into some difficulties here with the space surrounding this socket where you should connect the keyboard. And also you have poor markings. You have these diodes here. I actually had to measure out from the schematics to see where the anode and cathode on these diodes should be connected. And you have some components here that's not marked in any way. But here we see the biggest obstacle to this build. And here you have two openings for what should be 8-pin DIL sockets. And these chips is actually missing, and what is here is an op-amp and a comparator. I'm not sure how much they differ from each other, but this is the tape interface. So and this is specified with some special Russian chips, and there are some equivalents with European chips, but I haven't found any yet that's pin by pin compatible with these chips. I'm pretty close to one of them, but the other one I have not been able to trace anything. So while I might be able to finish this kit and make this computer boot, I will not be able to load any software from tape until this part of the circuit is ready. And there are also some poor markings when it comes to the connection here. I think these 5 pins here are the joystick interface. I have not measured that out yet, but if you take a close look on this, you actually have no markings and ready-made connectors for power supply. You don't have something that's marked with plus 5 volt and ground. And the same can be said about the speaker output and about the other outputs. There are some markings around here and here. That's probably is some space for these connectors. You also have something up here. But I really have to measure this out from the schematic to say what goes where. So this is some problematic craftsmanship, and of course this is made worse by that everything that's documented on this and every fix and hack that's done on this is written in the Russian language, and although I can understand some of it, it's when it gets very technical, I of course can't follow up on that. So this concludes this for this part. I will come back with another video where I place the chips on the board, and I will try to figure out where I connect the power supply, and we will connect the RGB outputs down here and actually see if we can get some life into this. So when we see if this boots, we see where this will lead us in the follow-up on this. So thanks for watching. That's it for this episode. There will be one more episode at least in this series. where we will try to get this one to work. And if I can get hold of the ICs that should be placed here, I will come back with an update on that too. So please subscribe if you want to see more videos made by me, and see you again in the next video. Thanks.